Hi, this is Dr. John Bergduff. In this video, we're going to talk about taking a number written in base 10 and converting it to an equivalent number in a different base. If you've been watching my videos, there's a companion video, so to speak, that asks us to do the reverse. Take a number in a different base and convert it to base 10. If you look at that video, you'll kind of see that what we're going to do in this video is almost what we did in that video in reverse. Let's jump right in. So suppose we have this base 10 number, 357 with base 10, and I'd like to rewrite it in base 5. Basically, what I'm going to end up doing is I'm going to attempt to write that number 357 in expanded form using powers of 5. 5 to the 1 is 5, 5 squared is 25, 5 to the third is 125, and farther if we need to go with that. Because if I can write that in an expanded form, then I can visualize the number in terms of base 5 blocks and think in terms of how many units, longs, flats, and cubes, and other things I might need. And from that, I would be able to basically just easily interpret what the base 5 number would be. So we have to ask ourselves, what powers of 5 construct the number 357? And as a start to that, you really have to ask this question. What is the largest power of 5 that's less than 357? Well, 5 to the 1 is 5, and that's well under 357. 5 squared would be 25, and that's still well under 357. 5 to the third is 125, still less than 357. 5 to the fourth is 625. We have gone too far. There's no way that 625 would divide into 357, so we do not need to go as far as 5 to the fourth. However, what we do believe is that the number 357 could be broken apart and expressed as a sum of something times the power of 5 cubed, plus something times the power of 5 squared, plus something times 5 to the 1, plus perhaps some units. Once we find the highest power of 5 that will divide into 357, what we do is we ask ourselves the question, how many factors of 5 cubed can be found in this number we're looking at? And that means taking the number 5 cubed, which is also known as 125, dividing 125 into 357, and we basically have to do that the old-fashioned way, by long division, so that we can see how many times that goes into 357 and what would be left. So 357 divided by 125, or 125 goes into 357 2 times, and 2 times 125 is 250. We subtract and get 107, and that tells me that there are 2 factors of 5 cubed in 357. No more. What we then can do is look at the remainder that we got from this division and say, well, 5 to the third will not divide into that, but 5 squared will. So we ask ourselves, how many factors of 5 squared are in the remainder? What was left? And that simply says, well, knowing that 5 squared is 25, how many times does 25 go into 107? It goes 4 times. 4 times 25 is 100, with 7 left over. So there are 4 factors of 5 squared in that remainder of 107. And we basically work our way down. We figured out how many powers of 5 cubed go into the original number, how many powers of 5 squared go into the remainder. Now we look at the remainder of this division we just did, and we ask ourselves how many of the next lowest power of 5 will divide into that. I'm going to need a little bit more workspace, so let me erase some things here. And remember, we're looking at 7, and we basically want to ask ourselves how many factors of 5 to the 1 are in the new remainder of 7. And I simply divide 5 into 7. It only goes one time, as you can tell. And the remainder of 2 would mean that there is one factor of 5 to the 1 in that remainder of 7. That's a 5. And then we'd have a remainder of 2. Whoops, sorry. So we would have 2 as a remainder. Now I would like to take those facts and write them in a different form. So what I would like to do now is interpret how this information that I have right here tells me how to write the number 357 in expanded form using powers of 5. So what all of that is telling me is that the number 357 is 2 times 5 to the third, that's this row, plus 4 times 5 squared, that's this row. Whoops, let me change that. Sorry, 4 times 5 squared, plus 1 times 5, there's 1 5, plus 2 left over. So 2 factors of 5 cubed, 2 times 5 cubed, plus 4 times 5 squared, plus 1 times 5, plus 2. That's expanded form of 357 in powers of 5. That's what we want to accomplish right there. Now I'd like to write that in a different but equivalent form by creating a chart which emphasizes to me how many of each of these different powers of 5 are represented. So let's do that this way. I'm going to create a chart, and you're going to see what I'm going to do with this later. So let me start here and have basically a free row, and I'm going to make a column for 5 cubes, a column for 5 squareds, a column for 5 to the 1s, and a column for 1s. To take that expanded form and write it in a chart to represent how much of each of those that I have. And looking back, there's 2 factors of 5 cubed, 4 of 5 squared, 1 of 5, and 2 of the remainder. So 2 of these, 4 of these, 1 of these, and 2 of these. Now, the reason I wanted to write it like that is because basically in base 5, what we have here are our units, our longs, because there are 5 units in a long, our flats, and our cubes. And if I write this in this chart like that, then basically the number in base 5 jumps right out at me, because my place values in base 5 are 1s, 5s, 5 squareds, and cubes, or cubes, flats, longs, and units. Our number is simply this bottom row, and it is 2, 4, 1, 2 expressed in base 5. That's it. That's how you make that conversion. Let's do another example. Now that we've seen one, and a second one will probably nail it home. Let's do the same thing where we want to look at a number, let's say, but have it be rewritten in base 12. So regardless of what the base is, you basically start with this same question. What's the largest power of that base that will be less than 1150, so that it'll divide into 1150? And what you do with any base is this. You ask yourself, okay, what's 12 to the 1, or whatever the base is, and that's clearly less than 1150. So you say, well, what about 12 squared? 12 squared is 144. That's also clearly less than 1150. What's 12 to the third? I'm using my handy calculator to help me out there. 12 to the third is 1,728, and that's too big. 1,728 won't divide into 1150. But this is sort of what you have to do. You have to go one power too far to know how to go back and know which power you need. So our questions will be, first of all, beginning with the 12 squared, how many times would 12 squared divide into the number we're given? And again, we have to do this long division style, so nothing terribly high-tech that we can do. This will go 7 times, and 144 times 7, I'm using my calculator a little bit, would give me 1,008, which gives me a remainder of 142. So there are 7 factors of 12 squared. That number there is important. Then you work your way down the powers of 12 and ask yourself, well, how many times does 12 go into, this is going to be not enough space. Let me try again. How many times does 12 go into the remainder that you just found? So how many times does 12 go into 142? And we do that division. 142 divided by 12 goes 11 times. And 11 times 12 is 132. So there'd be 10 left over. And that means that there would be 11 factors of 12 to the 1 and 10 as a remainder. This work here will lead us to expanded form. It will tell us that the number 1150 is 7 times 12 squared plus 11 times 12 to the 1 plus 10 left over. Let me look back so you can see that there. 7 factors of 12 squared, 11 factors of 12 to the 1, 10 as a remainder. That's this number. And that's useful, but I want to take that and convert it into a table where I'm eventually going to show my flats, longs, and units, which correspond to the ones place, the 12s, the 12 to the firsts, and the 12 squareds. We don't need cubes this time. And in our chart, we'll simply say how many of each do we need. We need 7 12 squareds, 11 12s, and 10 units. And basically, the number that you see across the bottom is the base 12 number. So we're doing a lot of things in different formats, but that gives me how many of each we have, and that gives me my place values: 10 ones, 11 12s, 7 12 squareds. Now, we do have to remember one thing. If I were to forget this, I might write the number as 7, 11, 10, like that. But if you do that, you realize you've introduced way too many place values. You now have the 1s, 12s, 12 squareds, 12 cubes, 12 to the 4ths, because each digit would be a place value. And that's way different from what the mathematics we got, so that's not right. What we have to remember is in base 12 and in any base greater than 10, there have to be special symbols for any number you get that is bigger than the base. So you might remember in base 12, the number 10 is represented by the letter E, and the number 11 is is represented by the letter T, which stands for 10, T for 10, and the number 11 is represented by the letter E, which stands for 11. T for 10, E for 11. So the way we actually have to write this number is 7ET, and that would be our number in base 12, reading it straight off of the table of powers of 12 or units, longs, and flats. So there you go. A little bit more complicated process, but I hope that makes sense and gives you a way to convert from a base 10 numeral into some other base.